In this example, we are given a circuit, and that circuit has a bunch of elements in it, and we have revealed some of these elements now that we know what sources are. So you see in the circuit in here, we have 3 different sources. So the first one in here, because it's a circle, I know that it's an independent, and because of the arrow inside it, I know it's a current source. So it's an independent current source that provides 2 amps regardless of what's happening in the circuit. Similarly, in here, you will see I have a voltage source because it has polarity inside it, and it's an independent voltage source that provides 4 volts regardless of what's happening in the circuit. And in here, I have a dependent source because it's not a circuit, and it's a voltage source because it has a polarity inside it, and it depends on something. And the way we figure out what that something is by looking at the equation next to it, this tells me it's 8I of x, so it depends on a current within the circuit. And if you take a look at that in here, you will see that the I of x is somewhere here. Actually, it's specifically here, it's 2 amps. Okay, so this is 8 times I of x. Okay, so this is a voltage source that depends on the value of this particular current. And we have other elements. So what we're being asked to do is the following. We are given this I of 0, okay, and we were not given what the value of I of 0. We were giving all the other voltages and current throughout all the elements except this particular one, and we were asked to compute it. And in this particular exercise, we will be using conservation of energy to figure out what this I of 0 is. Throughout the semester, we're going to learn different analysis methods that will tell us all the voltages and the currents, and we will be given less and less. In here, I have a bunch of voltages and currents, but later on, you're going to see that we have less and less information. Maybe none of the currents will be provided, and you will be able to figure it out based on the different analysis techniques. But in this particular exercise, we were told use the conservation of energy, meaning compute the power of all the elements, including the voltage sources and the current sources, including all these sources, and sum them, and they should add up to 0. And using this particular concept, you should be able to figure out what I of 0 is. So let's get started by computing what these different powers are. So I'm going to start with the elements, or the items, or the circuit elements that are numbered in here, the ones that we don't know what they are because they're boxes, and we'll compute them. So we'll start with P of 1. Well, P of 1 tells me that you have to multiply the voltage times the current. Well, the voltage across it is 6. The current is I of 0, so I'm going to do that in here. So it's 6 I of 0. And of course, passive sign convention applies. Passive sign convention tells me that there's a current in here, and it's hitting the positive terminal first. Because it's hitting the positive terminal first, I have to put positive in here. So it's 6 I of 0. All right, we move on to the next element in here, that. And again, similarly, I'm going to compute its power, P of 2. It's actually, I'm going to see what's the voltage, it's 2. What's the current? It's 9. I'm just going to multiply 12 times 9. But of course, passive sign convention tells me the current is going here, so it's hitting the negative port first. So I'm going to actually just take a look and just put negative in here. And of course, 12 times 9 is simply negative 108. And because all the units here are amps and voltages, that means the unit in here is actually watts. They don't have to be all the same, but in this particular circuit, everything that we are given are voltages and amps. We don't have milliamps or millivolts or kilovolts or so forth. All right, moving on, we see P of 3. But before I move on, I want you to pay attention that the power that we got for this particular element happened to be negative. That means this element, even though it might or might not be a source, is actually providing power. It's generating power. Okay, so P3 in here, that's P3. Again, we have to see what's the voltage. The voltage is 10 and the current is 3. We just multiply 10 times 3, but of course passive sign convention applies. Again, passive sign convention, the current is going to it. I'm going to see that it's hitting the negative port first, so it's actually a negative in here. So it's again negative 30 watts. I'm saying again because this element happened to be also generating power, because this power is actually negative. All right, so we're done with these numbered elements. So we move on to the sources. Sources also have power. So I'm going to take a look at this current source first. So I'm going to say P 2 of amp, or for the 2 amp. Okay, I know that the voltage across it in here is actually 6 volts and the current is 2. So all I have to do is just multiply 6 times 2. But of course, passive sign convention tells me, well, the current is going that way and it's hitting the negative port first. So I'm going to have to put negative in here. So that's negative 12 watts. All right. We'll move on to this voltage source in here. So this voltage source happened to be here, that's P, I'm going to call it 4 volts because it's providing 4 volts. Well, the voltage across it is 4 volts and the current is 8, so I'm going to have to multiply 4 times 8. And of course, passive sign convention tells me, well, the current is going that way and it's hitting the negative first, so I'm going to have to put a negative in here, and that's negative 32 watts. So as it turns out that this source have a negative power and this source have a negative power, so they're both providing power. All right, so let's move to the dependent source in here, and let's multiply its voltage times its current. So I'm going to call it P of D for dependent. Well, what's the voltage? Well, I'm going to take a look in here. I don't have a value. I mean, of course I can compute it, but typically when you see a dependent source, it's as straightforward as using the voltage source in here. Instead of putting 4, just put that equation, and then you can substitute later on. So the equation tells me that the voltage is 8 times I of X. Okay, that's the voltage. What about the current? Well, the current in here is 11 amps, so I'm going to multiply it by 11. Passive sign convention still applies. So I have current going that way, okay? And of course the current is going that way and it's hitting the positive sign. That means, or the positive terminal. That means I have to put positive in here. All right, well, I have a value for I of X, because if I take a look in here, I see that I of X happen to be 2 amps. We were given that. So I can substitute 8 times 2 times 11. And I will get 8 times 2 times 11 is 176. So it's interesting because I got that this particular source happened to be absorbing power because it has a positive power in here. So not all sources provide power. Some sources will consume power, some will provide power, because sources do not only represent batteries and power generators. They can sometimes represent other electronic devices and maybe motors that actually consume power. Anyway, we're not done yet. What we need to do, we're asked to compute I of 0, and the way we do it is by conservation of energy. So let's sum up all these powers in here that I'm highlighting, and we set them up to 0. Once we do, we will get an equation that will help us figure out what I of 0 is. So 6 I of 0, negative 108, negative 30, negative 12, negative 32, plus 176 equals 0. That's a simple equation. Solving it should give us what the power, or what I of 0 is. And you will see that by cleaning up this equation or solving this basic linear algebra equation, it's not linear algebra, it's just an algebra equation, you'll see that this is 1 amp. So the current that is in here is simply just 1 amp. And we can figure out what the exact power that is being absorbed or provided for this particular equation, which is 6 times 1. It's actually 6 watts. So it just happened to be that this particular element, which is element 1, is actually consuming power. So element 1 is consuming power, element 2 is providing power, element 3 is providing power. I'm looking at these signs in here, and that's what's telling me. The current source in here, it's negative, so it's providing power. The voltage source here, it's actually negative, so it's providing power. And this voltage source in here is actually consuming power.